Hi guys, welcome to Budget Power Electrical Solutions. In this episode, we're going to learn the electrical drawing symbols that every electrical student, apprentice, exam candidate, technician, and field electrician should know. These symbols are used in motor control circuits, PLC drawings, machine schematics, and industrial electrical systems. Understanding them is important not only for exams, but also for real-world installation, maintenance, troubleshooting, and electrical work in the field. For each symbol, first try to recognize it. Then we'll reveal the answer, look at the real component, and see where it is actually used. So, let's begin with symbol number 1. Here's our first symbol. You've probably seen this many times in electrical drawings. Can you identify it? Let's check the answer. The answer is normally open contact, or N/O. In the normal condition, the contact is open. When the push button is pressed, it closes and allows current to flow. This is also called a momentary contact because it changes state only while the button is being pressed. It is commonly used for start push buttons in motor control and industrial control circuits. Now let's see where this normally open contact is used in the real world. A start push button can energize a contactor coil to start a motor or machine. The same type of contact can also send a signal directly to a PLC input. So whenever you see this symbol in a drawing, think momentary start command from the push button to the control system. Here is symbol number 2. You may have seen this symbol in control circuits and stop button circuits. Can you identify it? Let's check the answer. The answer is normally closed contact, or N/C. In the normal condition, the contact is closed, so current can pass through it. When the push button is pressed, the contact opens and interrupts the circuit. This is also a momentary contact because it changes state only while it is being pressed and then returns to its normal condition when released. It is commonly used for stop push buttons in control circuits. Now let's see where this symbol is used in the real world. A normally closed stop push button is placed in series with the contactor coil in the control circuit. During normal operation, the circuit remains closed. When the stop button is pressed, the circuit opens, the contactor coil de-energizes, and the motor or machine stops. This type of contact can also send a stop signal to a PLC input or be used in a safety-related control circuit. Here is symbol number 3. You will see this symbol very often in motor control drawings. Can you identify it? Let's check the answer. The answer is the contactor coil, usually identified as KM. Its terminals are commonly marked A1 and A2. When the correct control voltage is applied to the coil, it creates a magnetic field and pulls in the contactor mechanism, operating the main and auxiliary contacts. Now let's connect it with the symbols we already learned. The normally closed stop button and normally open start button control the KM1 contactor coil. When KM1 energizes, the contactor closes its main power contacts and the motor can start. The same contactor coil can also be controlled by a PLC output in an automated system. Here is symbol number 4. You will often see this symbol in the power side of motor control drawings. Can you identify it? Let's check the answer. The answer is contactor main contacts. These are usually 3 normally open power contacts for a 3-phase circuit. When the KM coil is de-energized, the contacts remain open. When the coil energizes, all 3 contacts close together and connect L1, L2, L3 to T1, T2, T3. These main contacts carry the motor load current. Now let's see how they are used. In a DOL motor circuit, the 3-phase supply passes through the breaker, then through the contactor main contacts, through the overload relay, and finally to the motor. When KM1 energizes, the main contacts close and supply power to the motor. When the coil drops out, the contacts open and disconnect the motor from the supply. Here is symbol number 5. These contacts are very common in motor control and relay circuits. Can you identify them? Let's check the answer. The answer is contactor auxiliary contacts. The normally open auxiliary contact is commonly numbered 13 to 14 and the normally closed contact 21 to 22. These are low current control contacts, and they change state when the contactor coil energizes. They are commonly used for holding circuits, interlocking, and indication. Now let's see the most common application. When the start button energizes KM1, the 13 to 14 normally open auxiliary contact closes and creates a holding, or seal-in, path. This keeps the contactor coil energized even after the start button is released. Auxiliary contacts can also be used for electrical interlocks and status indication. Here is symbol number 6. You will often see this contact in motor protection and control circuits. Can you identify it? Let's check the answer. The answer is the overload relay normally closed contact, terminals 95 and 96. During normal operation, this contact stays closed. If the overload relay trips, 95 to 96 opens and interrupts the control circuit. The overload relay may also have 97 to 98 normally open contacts for trip indication. Now let's see how it protects the motor. The 95 to 96 contact is connected in series with the contactor coil circuit. During normal operation, it stays closed, allowing KM1 to remain energized. If an overload occurs, 95 to 96 opens, the contactor coil de-energizes, and the motor stops. So this small control contact plays an important role in motor overload protection. Here is symbol number 7. You will often see this symbol in machine control and automation drawings. Can you identify it? Let's check the answer. The answer is a limit switch. A limit switch is a mechanical position switch. When the actuator is moved by a machine part, its internal contact changes state. Depending on the application, it can use normally open or normally closed contacts. Common types include roller lever, plunger, adjustable lever arm, and heavy-duty limit switches. Now let's see how it is used in the real world. When a moving machine part reaches the limit switch, the switch changes state and sends a signal to the PLC input or control circuit. This signal can stop a motor, confirm end of travel, indicate machine position, or start the next step in the sequence. That is why limit switches are commonly used on conveyors, doors, actuators, and industrial machines. Here is symbol number 8. You will often see this symbol in automation and sensor circuits. Can you identify it? Let's check the answer. The answer is a proximity sensor. A proximity sensor is a non-contact sensing device. It detects an object and changes its output state without physical contact. These sensors are commonly used to send a signal to a PLC input. Common types include inductive, capacitive, cylindrical, and flush mount sensors. Now let's see where it is used. When an object approaches the proximity sensor, the sensor detects it and sends a signal to the PLC input or control circuit. That signal can be used for part detection, counting, position sensing, stopping a motor, or starting the next action. That is why proximity sensors are very common on conveyors and industrial machines. Here is symbol number 9. This symbol is very common in conveyor, packaging, and automation systems. Can you identify it? Let's check the answer. The answer is a photoelectric sensor. A photoelectric sensor is a non-contact optical sensing device. It detects an object by using a light beam or reflected light. These sensors are commonly used to send a signal to a PLC input. Common types include through beam, retroreflective, diffuse photoelectric, and forked photoelectric sensors. Now let's see where it is used. When an object enters the light beam, the photoelectric sensor detects it and sends a signal to the PLC input or control circuit. That signal can be used for product detection, counting, stopping a conveyor, or starting the next action. That is why photoelectric sensors are very common on conveyors, packaging machines, and industrial automation systems. Here is symbol number 10. This symbol is commonly used in pneumatic, hydraulic, and industrial automation drawings. Can you identify it? Let's check the answer. The answer is a solenoid valve, also called a solenoid-operated directional control valve. A solenoid valve is an electrically operated valve. When the solenoid coil is energized, it changes the valve position and controls the flow of air, water, or other fluid. Now, an important point here is how to read valve symbols, such as 3/2 or 5/2. The first number shows the number of ports. The second number shows the number of positions. So, 3/2 valve means 3 ports and 2 positions. 5/2 valve means 5 ports and 2 positions. A 3/2 valve is commonly used for simple on-off air control or with a single-acting cylinder. A 5/2 valve is commonly used for a double-acting cylinder, where air must be directed to one side and then to the other side. That is why in industrial drawings, understanding the valve symbol is very important. Now let's see where it is used in practice. A PLC output or a control relay can energize the solenoid coil. When the coil energizes, The valve changes position and redirects the airflow path. As a result, a pneumatic cylinder or actuator moves. So the sequence is: electrical signal solenoid coil energizes valve, changes position, airflow, changes actuator, moves. This is why solenoid valves are widely used in automation systems, machine control, pneumatic panels, and industrial processes. If it is a 3/2 valve, it is often used for simpler control applications. If it is a 5/2 valve, it is very common for double-acting cylinder control, where the actuator must move forward and backward. Thank you for watching Budget Power Electrical Solutions. If you learned something from this episode, don't forget to subscribe and turn on the bell icon so you don't miss the next episode. We'll continue with more important electrical drawing symbols in episode 2. Thank you again, and I'll see you in the next episode.